Alrighty. This is Mrs. Oliver bringing you today's 7th grade math lesson. All right, today we are starting our second unit on algebraic expressions. Okay, these are different than equations because they don't have an equal sign. Okay, so normally you're given some type of value to replace a variable with, and then you would solve it. Okay, this is lesson 5. So, chapter 5, lesson 1 in your textbook if you need to refer for any other notes or practice problems. And we are going to do some problems out of our book today. So, you're going to want to get your volume 2 and open it up to our chapter 5. Okay. So our objective today is that we will evaluate algebraic expressions. So here in our balloon, you can see an algebraic expression. Okay, you have 11 times the difference of e and 2. What we already know is we know how to add, subtract, multiply, and divide rational numbers. Okay, rational numbers are your positive and negative decimals and fractions, and our integers that are positive and negative whole numbers. Okay, so that's what we just finished up doing. Reason why we need this is because as we go on, as you get to higher grades, you're going to have complex equations, such as the one here up in the sky. Okay, it looks tough, but as you learn and develop your skills for this in 7th grade, is going to make it much easier as you get to your higher levels. So, if anything, if you get stuck and you really don't know what you're supposed to be doing, review those notes. Send a message to your teacher. Let them know where you're getting stuck, not just that I don't get it. Okay, that doesn't tell us much other than you're not really putting in a lot of effort. You've got to look for where you're getting stuck. Okay, so as we go through today's lesson, which is a very easy intro to algebraic expressions, if you get stuck somewhere, note it so that you know where you're getting stuck and can reach out to your teachers. And as always, this is a video, so you can pause it, rewatch it, fill in your notes as you need to. Okay? So we are going to start a new unit. Okay, so it is going to be textbook lesson, and then we'll fill that in. Page 20 is where we're filling in our notes today. Okay, so page 20 is writing and evaluating algebraic expressions. We are doing unit 2, which is expressions, and this is chapter 5 in our textbook. Okay, so fill that in so then you know where you can find everything that you need for this unit. Being organized is really the key to being a successful scholar. All right, so let's start. What is algebraic expressions? What is the components that make this? Okay, because we need to be able to write them and evaluate them. So we know that a variable is a letter that represents a number. The most common one is x, but that's not the only variable we can use. We can use any letter in the alphabet. Okay. Algebraic expression consists of one or more variables along with one or more arithmetic operation. So as long as you have at least one variable in at least one operation, whether it's addition, subtraction, multiplication, or division, and there's no equal sign, that is in your algebraic expression. Okay? And then the word evaluate. Okay? That means to find the answer or the value of your expression to compute or solve if you're giving for a value for that variable to plug in. Okay? You need to pause this, fill in your notes. We're going to hop down to finding some our key words that we need that mean for each operation. So I have some words down here that I'm going to drag them up to which operation they mean, whether it is addition, subtraction, multiplication, or division. Because that when we go to write the expressions from word form, we need to know what these words mean so we know that we're writing the correct expression. Right? So if I start with multiply, we know that means to multiply. So that one's easy. Right? All together. I want to know how many students we have all together. We add them up. Take away, right? If you take away something, you are subtracting. And obviously, plus is the elementary word for addition. Okay? More than. If I have 5 cookies more than my daughter, that means I would take her value and add 5 to it. Minus, that's our elementary word for our subtraction. Twice. If you have twice as many problems as Joe, that means you would take how many problems Joe has and multiply by 2. Then half of, instead of multiplying by 2, we're going to divide by 2. Okay? If you have a half of, a third of, a quarter of, that tells you that you're going to divide and by how much. If you have more than somebody, that's going to be your more than. Times, that's for multiplication. Less. If you have less than, you're taking that number away. Divide. Okay? Those are some of the more common that you know for sure that they mean addition, subtraction, multiplication, or division. What about decreased by? Okay, that means you're taking away. The number should be getting smaller. Same thing. Increased by is the opposite of decrease. All right, last unit we talked about the word of, how we knew if you had half of something, you multiplied it by that fraction. A ratio, we'll get more into ratios when we get into about Thanksgiving, Christmas time possibly, that we will have ratio of a fraction, and that means to divide. The sum, that means that we need to add to find the sum. That's your answer. Quotient is your answer to a division problem. Difference is what we call the answer to our subtraction. Product is the answer of a multiplication problem. Right? Subtract. And then less than is the same as subtract. Okay, if you need to, pause this, fill in your notes. Right? And now we're going to practice actually writing some expressions with what we have learned. So we got to look for those keywords, like we said. And when we find our keywords, we can write our expression. So the first one, the difference between a number x, that's our variable that they gave us, and 10. All right, so the difference, that's our keyword. That's telling me I need to subtract. So I'm going to take my x minus 10. Okay, and that's it. That's all you got to do if you're writing the expression. Didn't ask me to evaluate or to compute. It just wants to know what expression would represent this statement. Okay, our next one, the sum of a number y and 7. So the sum means that we're going to add, and the variable they gave us is y. If they give us a variable, you want to use the same one they gave you. And then we're adding 7 to it. Okay, so y plus 7, that is the sum of a number y and 7. 3, a number z decreased by 6. Okay, so that means decrease was that we're subtracting. Now I'm taking 6 away, and I started at z, so z is my variable. Okay, so z minus 6. 4, a number b less 8. Okay, so if we have the number b less 8, we're going to want to start with our b, and then we're taking away 8. Okay, so b minus 8. Now 5 is one where I see some kids get stuck, because if you don't really think about what they're telling you, you get your order mixed up. Okay, so 8 less than. Right there tells me how much I'm taking away. I'm taking 8 away from something. And it told us the number C. So C minus 8. Okay, that's where looking for those keywords and knowing what they mean is going to help you. All right, let's go up to 6. 4 times a number, x. So we know we have a multiplication problem. Now when we write multiplication with a variable, the value number comes first and then the variable. So this is our coefficient and then this is our variable. We don't write it x4, okay? It's 4x. A number p divided by 7. Okay, so we're starting with p. Oops, kind of looks more like a d. And we're going to divide it into 7 parts. Another way you could write this is as a fraction. You could also write it as p and put it over 7. Those are the same ones. Okay? 8, a number m multiplied by 9. Okay, so once we know we're multiplying, but we're going to put our coefficient first. I'm going to put my 9 and then my m. So I have 9m. That means we have 9 sets of whatever this m value is. 5, greater than half of a number t. So that means we're taking our t, we're cutting it in half. So when we take something and divide it in half, we are dividing by 2. Okay, so a t over 2. We're going to add, because it says greater than, our 5 to it. So t divided by 2 plus 5. Okay, number 10. 3 times a number x subtracted from 24. So from 24 means that's where I'm starting. I'm starting with 24. And then I'm going to subtract that 3x. Okay, so if you need to, pause this to fill in your notes before moving on. All right, here we have evaluate the expression for c, which equals 8. So what that means is that I'm going to replace the variable c everywhere I see it before these 6 problems with an 8. That's the value of c. And then for our value of d, we're going to replace it with -5. So when I look at this first one, I want to put 8 minus 3. And then I'm going to put equals 5 because that is me evaluating it. Okay. So for b, I go 15 minus, and then, well, what's the value of c? It is 8. So you would put 15 minus 8, then solve it to be 7. Okay. C, I forgot to hide that one. You're going to get 3 times the sum of 8 minus 8 plus a -5. The flashing's throwing me off. I'm sorry for the flashing, guys. Right? And then 8 plus -5 actually equals 3. So that's why this says 3 times 3. So I have to take the product of the sum, 3 times the sum, to get that, which then our final answer is actually 9. Okay, if you need to fix that, go ahead and fill it into your paper. I'm going to try to scroll down and get rid of the flashiness. Okay, next we have 2c minus 4d. So we have 2 multiplications. I have to multiply my 2 and c and then subtract the product away from it. Okay, so after I fill that in, we get really a 16 minus a -20. Well, from last unit, we learned that we have to turn it into addition with adding the opposite. So we are really adding a positive 20 to our 16 to get 30. Okay. All right. E has what we call a square. Okay, that's our exponent. This means a C times C. So when I fill it in, I actually have a negative 5 minus the product of 8 times 8, which is 64. Then I add my opposite, so I have two negatives, and I get it equals a negative 69. All right, if you didn't get that, fix it. F. Again, we have a multiplication, then exponent. Then we're adding another product. Remember your order of operations, you have to do exponents before you can do multiplication. So I have to take the value of d times d, so that negative 5 times negative 5 first, which gives me that 25. Okay, oops. And then I take my 5 times negative 5 to get my negative 25. Break it down. Okay, you don't have to do it all in your head at once. You can break it down little by little to get a positive 25 for your answer. Okay, if you need to, you pause this and fill it in. We're going to talk about the candy shop. Okay, so we have the Sweet Tooth Candy Shop. Sells fudge for $4 per pound. Okay, that's another keyword, per. That's going to mean to multiply. And licorice for $3 for a pound. So if you buy multiple pounds, you would multiply how many pounds by 3. So our job is to write an expression that can be used to find the total cost of a purchase of fudge and licorice. Okay, so we get to come up with our own variables for this. Okay, they didn't tell us what to use. Normally when you're looking for variables, you want to look at what the first letter is of the word that represents the variable. So I'm going to use an F for fudge and an L for licorice. Going back to my problem, it is $4 per pound for your fudge, and our licorice is $3. Okay, so 4F plus a 3L, not a 31. Just the way the font looks, it looks like 31, but that is an L. Okay, we're going to use this to solve B. If Emily goes to the Sweet Tooth Candy Shop and she purchases 2 pounds of fudge but 4 pounds of licorice, what is her total cost? Okay, so what I want to do is replace my fudge with how many pounds? So replace the F with a 2 because you only got 2 pounds. I replace my L with the 4 for the 4 pounds. Then we multiply, which is 8 and 12. And then we add them. It is going to cost her $20 for her food. Okay, if you need to, fill this in, glue it into your notebook. Okay, now we're going to do some guided practice. Okay, first we're going to start at the top of 353. We're going to practice doing those 3 problems. So I'm going to highly suggest that you pause the video, try to solve these 3 problems, and then check your answers. Okay, if you can't figure out if you got the answers wrong, where you might have made your mistake, circle it so you know to talk to your teacher about this problem that you can't figure out. Okay, so pause. All right, so let's see what you got. For the first one, I got 34. Then number 2, I got 2, because I got to take D, which is 8, and divide it by 4. So that's 2. EF, that means we're taking E times F, which is 3 times 4, and dividing it by 4, which gives you 3. All right, your next guided practice 1 is at the bottom of the next page. Okay. There's like 4 questions under guided practice. All right, we're going to use these values in the expressions that they give us. Okay, so again, I highly challenge you to pause these, then come back and check your answers. Okay, it's not going to teach you anything if I just give you the answers without you practicing it. Okay, so do the problems, come back, do 1 through 3. And if you want, do the all 1 through 5, and then see what your answers are. All right, so for these, I got negative 10, then I got 31. At 3, I got a negative 384. Okay, these I did kind of show my work a little bit so that at least you could hopefully see if you didn't do something right, what mistake it was you made. Okay, now if you didn't pause it for to do number 4, pause it. You're going to come up with a expression. Okay, a website charges 99 cents to download a game. So if you do multiple games, you're going to have to do something with this 99. And a $12.49 membership fee. It's a one-time fee. Okay. So my expression that I wrote was that I'm going to take 99 cents times B for download, because every time you download, that's how much you get charged, plus your one-time membership fee. Replace it with your 6 for your 6 games, and then you multiply, and then always try to write your answers in a complete sentence restating the question. Okay, it costs $18.43 to download 6 games. All right, let's look at 5. We want to say, is this sometimes, always, or never true? And then we have to justify. That means we have to explain why we feel it is the way it is. So in the expression x minus 3 and then y minus 3, do they represent the same value? Sometimes. The only time that they can be the same is if x and y are actually the same value and they are equal to each other. That is the only time. Alrighty, so then that is it for our lesson. So you have everything filled in, ready and confident. Check back with your teacher's page on Google Classroom to see what your actual homework is. It should, believe, be out of the textbook, but check on there to see what your actual problem numbers are. All right, have a great day.